All right, so this is question 3 in the static equilibrium work package. And here we have two wires that are suspending a mass of 11 kilograms. So I'm going to call the one on the left T1 and the one on the right T2. Again, the angles are given from the vertical, so we have to use basic geometry to get the angles from the horizontal. So again, if the vertical angle is 60, that angle will be 30. And if this angle is 30, that angle would be 60. All right, so again, F net equals 0 newtons. And we can start by drawing our free body diagram. So we've got FG going down. We've got T2 going up and to the right. We've got T1 going up and to the left. We have T2X going to the right and T1X going to the left. We've got T1Y going up and T2Y also going up. And all forces are balanced. So again, X, Y. So again, if F net 0, 0 will equal T2X plus T1X. But T1X is negative. So automatically, T1X equals T2X. So using our geometry, T1X is T1 cos 60 degrees. That equals T2 cos 30 degrees. Again, the T1 angle, okay, is 60, and the T2 is 30. So we can isolate either one. We'll isolate T1. That will equal T2 cos 30 divided by cos 60. And that's our first equation, getting ready to solve. So now we go over to the y, to the vertical, and we realize that, okay, we've got to deal with FG that's going down and T1y and T2y. So 0 equals negative FG plus T1y plus T2y. So FG goes to the left, and we know it's going to be 11 times 9.8. So let's just get that ready. 11 times 9.8 equals T1y, which is T1 sine 60 plus T2 sine 30. All right, so we can do our math. 11 times 9.8, 107.8. 107.8 equals T1 sine 60 plus T2 sine 30. So now if we go back to our first equation, we did isolate T1. So where we have T1, we'll substitute the right-hand side. So we get 107.8 equals T2 cos 30 over cos 60 times sine 60 plus T2 sine 30. Notice sine over cos is tan. So we can replace this as 107.8 equals T2 times cos 30 times tan 30. And then we add T2 sine 30. So now we've got all our sines and coses and tans, and we can get the decimals now. So we'll do the first one. Tan 60. That's a mistake. That should say tan 60 times cos 30. Okay, and we know we're adding, I don't want to write the decimal, so we're going to add, okay, we're going to add sine 30, which we know is 0.5, but we'll still add it anyways, and we get 2. So 107.8 equals 2 times T2. Solve for T2. We take 107.8 divided by 2, 53.9, or about 54 newtons. And we back solve. So T1 will equal 53.9 times cos 30 divided by cos 60. So we take 53.9 times cos 30 divided by cos 60. You get 93.36. 93.36 newtons, and sig figs 93 newtons for T1, and T2 is 54 newtons. And we have solved question number 3. Static equilibrium, 2 tension forces, 2-dimensional, work from the FBD. Split up your x and y, equation 1, equation 2, and then substitute, solve for the first variable, and then back solve for the second. And that's that.